Section 6.1 is area between curves. So the first step is to draw a picture of the section that they give you. So the two equations they give you, graph those. The second is to clearly identify your region, where you're going to be integrating and that such. Step 3 is to decide how to slice your region. So you can either do that vertically or horizontally. Since you're not doing the volume yet, you don't need to, there's no specific way to do that. For step 4, you find and identify the intervals of integration. So if you're doing it vertically, you would find the B and the A on the x-axis, and that would be your intervals of integration. And step 5 is to set up the equation for the height of the representative rectangle. And so the final equation will be A equals the integral of your first equation minus the second equation. And if in certain cases you will have that A equals the integral of B to A on the absolute value of f of x minus g of x. Section 6.2 is volumes. So volume is the area times the height. So in this section, we'll be doing volume equals the integral of the cross-section times the thickness. So the common method we use for these equations are the disk and washer method, which are basically the same thing, just washer has 2 equations and disk only has 1. So the first step is to draw a picture. The second step is to clearly identify your region in which you will be integrating. Step 3 is to sketch a representative rectangle perpendicular to the axis of rotation. So you can either do that vertically or horizontally. Step 4 for disk would be to write one equation just for the only formula you have. For washer, you have to find 2 equations, one for the larger equation and one for the smaller equation. For step 5, you use the formula for these 2 methods. For disk, it would be the volume equals pi times the integral from b to a of the formula squared. For washer, it would be the volume equals pi times the integral from b to a of the large equation squared minus the smaller equation squared. So if you're doing these in terms of y, it would be the y top minus the y bottom, or in terms of x, it would be the x right equation minus the x left equation. Section 6.3 are volumes by cylindrical shells, so shell method. Shells are different than the washer method and disk method because the slices are parallel to the axis of rotation. So the equation for shells is v equals the integral of b to a 2 pi times the shell radius, which is perpendicular to the axis of rotation, times the shell height, which is parallel to the axis of rotation, then times dx or dy, considering which you would choose. So the first step is to draw the region. Step 2 is to sketch a line segment across parallel to the axis of rotation, which is your shell height. For step 3, you find the limits of integration for the thickness variable. So you choose if you need to use terms of x or terms of y. And step 4 is to integrate using the formula with respect to the thickness to find volume. Also, in section 6.5, we learn about the average / mean value of a function. And just to review on that topic, it is f of c equals 1 over b minus a times integral of b to a of fx in terms of dx.